Hello the internet and welcome back to my channel. Today on the bench we have a speaker amplifier module. This module belongs to a Genelec 1037B triamplified monitoring system. It's a pretty high-end speaker system, which it's very discontinued right now. I'm told that this board has a fault, so what we're going to do today, we're going to try and replicate that fault and see if we can fix it. So let me thank today's sponsor, PCB and let's try and see if I can replicate the issue first. The sound is coming through this connector here at the back and is going into the board, and it's a full range signal, so it's covering from 20 Hz to 20 kHz, which is the audible frequencies for a human being. Now, on an ideal world, there would be ideal drivers capable of reproducing all the frequencies from 20 Hz to 20 kHz. Now that's not the case, unfortunately, and a driver which is perfectly capable of playing high frequencies might not be able, will not be able to play low frequencies. So a good speaker usually ends up having more than one driver, usually two, one for the low frequencies and one for the high frequencies. Now, as I said, the signal going into the amplifier is full range, it covers all the frequencies, and unfortunately you can't send all the frequencies to a high frequency driver and the low frequency driver. The high frequency driver is probably going to break with low frequencies, and the low frequency driver is probably not going to do a good job with high frequencies. So we need a crossover, and there are two types of crossover. One is called the passive crossover. It lives inside your speaker, it's made of passive components like inductors, capacitors, and resistors. All you need is one single amplifier to amplify the whole spectrum, and the crossover will take care of splitting the spectrum into two in case of a two-way speaker, sending the high frequency to the high frequency driver and the low frequencies to the low frequency driver. Now, passive crossovers have several disadvantages. They are working after the amplifier with lots of power involved and high voltages and high currents. So the best solution in terms of sound quality is to have the crossover before the amplifier, so you're working on the signal level coming from your device, your guitar, your CD player. Apply the crossover at that level, either with an analog system or with a digital system, and then feed it to two separate amplifiers in case of a two-way system. One amplifier is only going to get the low frequencies and is only going to drive the low frequency driver. The other amplifier is getting only the high frequencies and is only going to drive the high frequency driver. So when I said that this speaker is a tri-amplified speaker, it means that the signal is coming here, full range, is being split into three: low frequencies, mid frequencies, and high frequencies. And those three signals are being fed to three completely independent amplifiers, which are then connected to three independent speakers for the best sound quality ever. Now, under this heatsink, I can count 6 big transistors, and that's expected for 3 amplifiers. We got one amplifier here, and one amplifier here. And you can actually see that basically the board is split into 3. This is one amplifier, this is another amplifier, and this is another amplifier again. Now, unfortunately, I can't find the schematics for these board. The Genelec apparently never released them, so I have to do a little bit of guessworking. But the board is more or less, I think, kind of simple to understand. Mains voltage is coming here, is going into this beautiful transformer. I've never seen anything like this. It's not like a standard transformer, it's not a toroidal transformer. It's got some ceramic insulation and this weird metal core in the middle. I guess is to reduce vibrations and to reduce any sort of noise. This is a pretty high-end sound device, so you don't want any buzzing noise coming out of your speaker. The output is going to be AC, and then I see on this vertical board here, I think it's the power distribution for the, let's call it V plus and V minus, the actual voltages used to generate the sound that actually goes to the speaker. I see a bridge rectifier here, which is probably set into a bipolar setup, so this bridge rectifier is not generating 0 and the voltage, it's generated minus V minus and plus something. So let's say plus 50 volts and minus 50 volts, because obviously you need to push the speaker forward but also backwards. So you need positive and negative voltages for that. After the bridge rectifier, we have two pretty big 10,000 microfarad capacitors. They're rated 63 volts, so maybe my guesswork of 50 volts of V plus is going to be correct. And then we have this board with very thick traces that I think is just going to distribute this voltage to the transistors, and then from the transistors we have the outputs coming to this connector here, which goes to the speakers. The audio signal is coming through this connector here. As I said, it's going to be full range, so it's going through a crossover, which I'm assuming is analog because I don't see anything digital on this board. And this is definitely where the crossover section lives, because I can see some dip switches here which are accessible from the outside of the speaker. And if we take a look, you can see that these switches are to set the high frequency level, the mid frequency level, the low frequency level, the low frequency tilt, and the low frequency roll off. You cannot change the crossover frequencies according to this graph. One is probably set to 400 Hz and one is probably set to 3000 Hz, but you can change the way the crossover is shaping the sound so that you can have a slightly different high frequency level, mid frequency level, bass level, and the way the low frequencies are interacting with your room. Now here, close where the transformer input is located, I see two voltage regulators. One is the 7815, one is the 7915, and these are generating the plus and minus 15 volts, and I'm assuming that these are required for the analog crossover section to work. When you have sound, you always have plus and minus something, even when it comes to line level signals, because the devices, the drivers or whatever, they need to be able to work with positive and negative voltages. Now I'm told that this amplifier works, but the low frequencies are disappearing randomly, and especially by tapping the board or moving the board a bit, it comes on and off. So hopefully it's going to be like a simple thing as reflowing a joint, or maybe we have a cracked component, that kind of stuff. But the first thing I need to do is to connect some speakers, power this up, send some noise, and try and replicate this problem, because I don't like to reflow everything and assume that it works, and then I send it back to the owner and then they telling me after a week it's come back. So I really would like to replicate the problem, hopefully identify where it's coming from and go and fix it. Then I might go on and reflow everything anyways, but I would like to be able to reproduce it. So the first thing I'm going to do, I'm going to plug some small speakers. I have these small speakers from an Apple monitor. They're going to be totally fine. Again, I'm going to use low power signals, so I'm not going to break anything, of course, but I need to find out what goes where. Schematics are unfortunately unavailable, and the owner hasn't told me anything about how the speakers on the cabinet are connected. So I've done a little bit of guesswork, and I think I found how to connect speakers to this board. Now, out of this smallest connector, I will have the high frequency driver connector, so there's 2 wires, the mid frequency driver, 2 more wires, and the low frequency driver, 2 more drives. Now, I don't have the complete speaker here, otherwise it would have been simple to understand what goes where, but looking at pictures online, I see there are 2 LEDs at the front of the speaker. One is the power on, and one is the clipping, which basically indicates when the amplifier, one of the amplifiers, is being overdriven. So the first thing I've done was to try and find out which one of these pins are the ground or the common pins for all the speakers. Now, on a sound device, you often have more than one ground to try and keep the noise out of the way. So the chassis, unfortunately, is not connected to any of these pins. And I got the multimeter in continuity mode, of course. I cannot trace anything here. So I've decided to use the ground pin of one of those regulators. And if I'm going to the 7815, the ground pin is the middle one. And when I connect it with that ground, I can see that the pins which I marked with the green dot are actually, let's call them ground or common. Got this one, not this one, this one, not this one, this one, not this one, not this one, and this one. Now, as I said, we have like 3 amplifiers here. We have amplifier 1, 2, and 3. And if I'm looking at the back, he actually said that this section here is the low frequency, this section here is the mid frequency, and this section here is the high frequency. Well, at least this is how the dip switches are located on the board. I doubt that the dip switches are following a different order than the actual amplifiers on the board. Now, this is a single layer PCB, so using this little trick, I can actually see the traces at the back, and I can see 3 big traces coming from these 3 coils. And also there's a big trace here, which is then linked in here, which is going to my ground points, let's call them that way. So this big trace here, for example, which is linked to this bridge here, it's my, let's call it ground. And then I have one big trace which is coming from this inductor here, which is going to say pin number 2, counting from the right. This other inductor is going to pin number 4. And this final inductor here, I couldn't find where it was going. I thought it was going to pin number 6. So that would be this one, but it's not actually. But then I realized this is going through a capacitor. Now, capacitors in series, they're used on low power signals to cut away low frequencies, because obviously if you send low frequencies to a high frequency driver, it will probably break. So if I'm looking at the traces, I see that the output of this inductor is going into this capacitor here, out of this capacitor, and then we have another big trace going to pin number 6, and I can actually buzz it if I touch the capacitor, the output of the capacitor. So if I understand correctly, the first 2 pins are going to be low frequency, then the next 2 pins are going to be the mid frequencies, and the following 2 pins are going to be the high frequencies, and the rest is going to be the power on LEDs, which I don't care at this stage. So what I'm going to do now, I'm going to make a connector with the 3 of the speakers, and one is going to act as a low frequency driver, one as a mid frequency driver, and one as a high frequency driver. Then I'll power on this thing, I'll send some sound out of it, and we'll try and replicate the problem. Alright, I wired the 3 speakers on this small X connector, which I'm gonna plug in here. There we go. And I've got this connected to my laptop, and I'll play some music. So I'll have to tilt this board. I'll also plug mains, then we'll power up, and we'll see if we get anything out of this. I've got everything connected, and I've got the multimeter in DC mode, and it should be wired to the V plus minus V plus. So we might get something like 100 volts if it's around 50 volts, as I suspect. I'm going through my current limiter just because, you know, it's mains, I'm working on it in case, touch wood, anything happens. So it might struggle a bit because we got some big capacitors, but eventually when the capacitors are charged, this should be fine. 3, 2, 1, go. Oh yes, we got 114 volts, so that is correct. We got about 55 volts DC, plus and minus, and we haven't got any sound because I haven't got anything playing, but it should be ready to play. Alright, it's working, and we got the HF, we got the MF, but I don't think we got the LF. Now, obviously, these are identical speakers. They shouldn't be like that. I should have an LF, a bigger driver, but I should be able to hear something out of the speaker. So, probably this is the fault that I'm told the board has. Let's try and tap the board while we play sound and see if anything changes. Oh, no. Actually, no, I'm mistaken. The speaker is definitely working if I'm touching it. I'm not sure whether it was working a moment ago. But so, no, this is not working. I can feel vibration out all of the 3 speakers. Let me do the opposite. Let me tap the board and see if the speaker stops working. Alright, so I couldn't replicate the problem, so I let this thing run for a while, because I'd imagine this is running probably 24/7 in an enclosed cabinet. Who knows what kind of temperatures it's getting. But still, it would work totally fine, and then I started playing with hot air, it would still run totally fine, and then suddenly the low frequencies disappeared, and I thought I understood what I was doing, so I recorded something, then the low frequency came back, it wasn't what I thought, then I recorded another one. Anyways, this is the 3rd time I'm recording, and meanwhile the low frequency has come back. So I'll have to be quick, but to better diagnose this problem, I've created a 200 Hz sine wave file with Audacity, and when I play this file, it sounds like this. I can totally see the driver working. There is a little bit spilling over the mid frequencies. It's kind of normal, but that's telling me the driver, the section, the low frequency section is totally working. Now, let me try and trigger the problem again, and then we'll try and find out how to fix it. And I found the problem, it's the connector itself. I tested it before, it wasn't definitely doing anything, so I guess it must be like a micro crack, which is being triggered by heat as well. With a cold board, it's probably not happening, but now it's happening all the time. So this is great, because I didn't want to reflow everything and then hope for the best, but now it's time to remove this board and take a look at the back. And when it comes to PCBs, 3D printing, metal sheet fabrication and CNC machining, I can only recommend PCBWay as your only stop for the best quality and the best customer service. I've been using PCBWay for all my projects for quite some time, really never had to complain about it. And the process is extremely easy. When it comes to PCB, you just need to find the Gerber file of the project of your choice and upload it on PCBWay.com. The system is more or less automatic, just follow the steps. I tend to change the color of my PCBs and then I just select a postal service and PCBWay will deliver the PCBs at my place. And I really love my 3D printed CPU trays, and the process to order them was as simple. Take a look at PCBWay.com to explore all the services, the link is also down below in the description, and let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible, so thank you very much PCBWay. Now let's continue with this Genelec amplifier. The transistors are insulated from the chassis by a strip of silicon pad. Over time, they got stuck to it. I tried my best and I couldn't free them up. I didn't want to damage the insulation as that might lead to a short circuit, so I tried all sort of plastic tools, but with no luck. There is an aluminium bar between the back panel and the transistors and a further silicon pad in between. I thought the pad was there to insulate the aluminium bar from the chassis, but no, the screws in between the various parts keep them electrically connected. The silicon pad is there only to maximize thermoconductivity. The transistors are insulated only by the upper silicon pad. Without realizing that, I decided that a little chipping on the aluminium parts was my only choice to release the parts, so I used the screwdriver as a chisel to release the whole thing. The damage was minimum and anyways not relevant for insulation purposes, but I'll fix it later anyways. And it seems that we have found our problem. These two pins on the right are the low frequencies, and these two are actually the mid frequencies, so maybe it wasn't obvious yet, but that was failing too. Both legs are clearly cracked. Now the high frequency pins are kind of okay, I don't see an issue here, but there is something happening with the rest of the pins. You can definitely see something going on. The bottom line is that all these pins, all this connector was about to fail everywhere. These are the legs at the end of the connector. I don't know, that could have been maybe one of the LEDs, and again, they're not in a better shape, so we need to reflow the whole thing, of course. Now, I went to take a look around the board to see if there was any other sign of butt joints, and I think I found this, which happens to be the transistor of the low frequency amplifier. I'm not entirely sure, but I think I see a crack in there. I think that's a crack, but I would need a different lighting to try and expose it. Well, whatever that is, it can't be a good thing, so I think I'll go around the board and reflow a bit everything, especially the larger solder joints. The adjacent pin is also about to crack if I see this right. Let me try from a different angle. And there is definitely a crack developing around the leg, though I've been hammering on those transistors a bit, so who knows, maybe it was me, but probably it was about to develop anyways at some point. This is the leg of the inductor of the low frequency output, and if there's no crack in there, it's definitely about to develop. And this is the connector coming from the main transformer. So yes, the board is full of cracks. I would say let's crack on and let's sort out all those bad solder joints. Now, I'm not the kind of person who replaces capacitors just for the sake of doing it, but just out of curiosity, I've removed these 3 capacitors. They are 1000 microfarad, 63 volts, they're only rated 85 degrees, so I'm curious to see what we're getting here. And I'm reading 925 and about 90 something milliohms of ESR, so that looks totally fine. This is 100 hertz, so that's like the worst case scenario. If I'm increasing the frequency, I would get better values. Next one is more or less reading the same, 910 and 96 milliohms of ESR. And the last one is 903 microfarad and 97 milliohms, so they all read the same, and to be honest, I think they read totally fine, so there's absolutely no need to replace them. Now, there are not many other electrolytic capacitors on this board. We got these 2, let's say, bull capacitors, just for the V plus and V minus, but these can be expensive, so honestly, I'd replace them only if there is a real need to do it. And then I have 2 capacitors per module here, which is closer to the outputs. Now, there's also a small potentiometer, which you probably can't see from there. Now, unfortunately, there's no service manual for this board, so I don't want to go and replace components on this board here, because I don't know how to readjust the board. There must be the bias, maybe the DC offset, something. There's no manual whatsoever, no service manual. There is one available, it's not available online, so I don't want to touch this area unless really necessary, because I wouldn't be able to readjust it. So I'd say let's reinstall these 3 capacitors, reassemble the board, give it a good clean, and test it, and I'm confident it's gonna work better than before. And as a final touch, I'm going to spray some contact cleaner for switches in these deep switches. I know for experience they can get dodgy, and if that happens, you may actually lose either the low frequencies, the mid frequencies, or the high frequencies. I'm also going to spray some into this trimmer, but not all the other trimmers, because those will need to be readjusted. This is the level input trimmer, so obviously it depends on the situation. It doesn't have a fixed adjustment. When reinstalling the board, I went ahead and fixed the little burrs created by me pulling the parts away with the screwdriver, without realizing that that was a known issue as the parts are electrically connected by screws anyways. However, those burrs could act as wedges and prevent a good adhesion. While working, I noticed the metal washer and I realized I had missed 2 screws under the heatsink, which had to be removed again. Now, a washer in that position doesn't make any sense whatsoever, but I left it there mostly because moving it would change the mechanical position of the transistors to the PCB, requiring the solder joints to be cleared to allow the components to reposition. Whether that was intentional or a mistake at the factory, I can only speculate. All I know is that the washer was there before I took it apart. Alright, I think everything is back as it's supposed to be. I don't see any shorts, so I'm ready to give it a go and make sure that everything works. As before, the multimeter is connected to V plus and V minus, so it should read something around 100 volts, at least I know that something is happening. And I'm ready to fire up in 3, 2, 1, go. Okay, we got 100 volts, and... and everything works totally fine. That is absolutely amazing, and the connector doesn't cause any problems. Of course, it was so obviously cracked that that was definitely the problem. Now, I'm almost done with this amplifier. While I was putting it back together, I've noticed something I think I'd like to take care of it. Let me show you. Now, earlier on in the video, I've noticed these brown spots in here. I don't know, I think there was some sort of adhesive. And as far as I understand, this should be the one that gets conductive over time. Though I did test it straight away earlier on in the video, and there is no conductivity at all. I got the multimeter in resistance mode, so it should read absolutely everything, and there's nothing here. So I thought, I don't need to worry too much about it. Also, these are the driver boards, at least it says here at the back. With the small potentiometer, I don't want to disturb that board at all, because again, I haven't got the service manual, I don't know how to realign it. That being said, and I'm not sure how much that is visible with the camera, I can see that that kind of glue has reached a leg of a transistor here. I don't know what the role of that transistor is, and I don't like it. So I think that leg is connected to the ground plane of this little PCB. So what I'm going to do, I'm going to reflow that bit, and I'm hoping that that will take care for future problems that might arise. So let me get my soldering iron out. I might go ahead and scrape it a little bit just to be on the safe side, and then I'll resolder it, and hopefully that will be okay. And it's working totally fine. Now, obviously, to properly test this amplifier, you need a speaker, you need a cabinet with the big drivers, and just push it a lot and make sure that everything works. But I'm confident, given the amount of cracked solder joints that we found and we fixed, I'm confident that this is going to be totally fine now. This is such a nice speaker, I'm so happy I've managed to salvage it. I've no idea what would have happened to it if I hadn't fixed it. Can you imagine a Genelec speaker like this thrown away because just of some solder joints? But hey, this is how it works today. We dispose of things and we buy new ones. I'm gonna return this amplifier to its owner, and I hope to have good news from them, as in the speaker is working totally fine and it's performing as brand new. I'm really sorry there's no service manual for this board. I would have loved to set up all these trimmers and to service this old board to bring it back to original specifications. Well, I guess that's it for today. I thoroughly enjoyed this repair. I hope you did as well, and if you did, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. Don't forget I'm on Facebook, on Twitter, and on Patreon, and the link is also down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, I completely understand. I appreciate your time, and I hope you had fun. Well, I wish you a great day, and hope to see you again soon here on my channel for my next videos. Thank you very much, and goodbye. Bye-bye.